Hi everyone, welcome back. Let us start question number 8 of exercise 11a. 0.5 kg of lemon squash at 30 degrees Celsius is placed in a refrigerator which can remove the heat at an average rate of 30 joule per second. So what is 30 joule per second? 30 joule per second is power. How long will it take to cool the lemon squash to 5 degrees Celsius? Initial temperature of the lemon squash was 30 degrees Celsius. Final temperature is 5 degrees Celsius. So temperature difference is 25. Remember, in calorimetry numericals, we will always consider delta T as positive. Otherwise, someone might think that TF minus TI should it not be minus 25 degrees Celsius? Yes, it is minus 25. But when we substitute the value of delta T in the numericals of calorimetry, make sure that you take delta T always positive. Alright, चलो आगे बढ़ते हैं. How long will it take to cool the lemon squash to 5 degrees Celsius? So we are asked to find out time. Specific heat capacity is given. Mass is also given. Mass 0.5 kg. Specific heat capacity 4200 joule per kg Kelvin. Now we already know that PT is equal to mass delta T, power 30, time we want to figure out, mass 0.5, or let me write half, specific heat capacity 4200, and delta T is 25. So this is 2100. T is equal to 2100 into 25 upon 30 divisible by 3, 70, 1750 second. Okay, 1750 seconds. This is the time taken to cool the lemon squash to 5 degrees Celsius. Numerical number 9. A mass of 50 gram of certain metal at 150 degrees Celsius is immersed in 100 gram of water at 11 degrees Celsius. The final temperature of the mixture is 20. Alright, so this numerical is based on the principle of, this numerical is based on method of mixture. What is the principle of method of mixture? It says that heat lost by hot substance is equal to heat gained by cold substance. But there is a condition. What is the condition? The condition is no heat is lost to the surrounding. No heat is lost to the atmosphere. No heat is lost to the surrounding. So under this condition, heat energy lost by hot substance is equal to heat energy gained by cold substance. So here in the question, let us figure out that which substance is hot. Okay, so metal is given and water is given. What is it? What is the mass of metal? 50 gram at 150 degrees Celsius. Okay, 150 degrees Celsius is immersed in 100 gram of water. 100 gram of water at 11 degrees Celsius. So now it's clear that metal is hot substance and water is cold substance. We want to find out specific heat capacity of metal. Specific heat capacity of water is given 4.2 joule per gram Kelvin, and the final temperature of the mixture is also given 20 degrees Celsius, meaning temperature of metal decreases from 120 to 20, 150 to 20, sorry, and the temperature of water increases from 11 to 20 degrees Celsius. So now we can write according to the principle of calorimetry, this statement is must. Heat lost is equal to heat gained. Heat lost, mass delta T. This is mass delta T for metal, and this is heat gain. Who gains the heat energy? Water gains the heat energy. Mass of metal 50 gram. Specific heat capacity we want to find out. Delta T for metal 150 minus 20 130 is equal to mass of water 100 gram, specific heat capacity 4.2, that is 42 upon 10, into delta T is 11 to 20 9. 10 and 10 here also gets cancelled. So now this is specific heat capacity is equal to 42 into 9 upon 50 into 13, and use your math scale to find out the answer, and at the end you will come to know that answer is 0.582 joule per kg Kelvin or gram Kelvin. Correct, gram into Kelvin. Why? Because here masses are given in gram. So unit of specific heat capacity here becomes joule per gram Kelvin. 10th, 45 gram of water at 50 degrees Celsius in a beaker is cooled when 50 gram of copper at 18 degrees Celsius is added to it. Another question based on the principle of method of mixture. The contents are stirred till the final temperature is reached. Calculate the final temperature. Alright, so water 45 gram at 50 degrees Celsius is in a beaker, and there is another substance added to it, copper. How much copper? 50 gram. At what temperature? 18 degrees Celsius. Contents are stirred till the final temperature is reached, and that final temperature we want to find out. Specific heat capacity of water 4.2 joule per gram Kelvin, and specific heat capacity of copper is 0.39 joule per gram Kelvin. So according to the principle of calorimetry, or you can say principle of mixture or principle of calorimetry, both are same. Heat lost is equal to heat gained. Heat lost. Who loses the heat energy? Which substance? Water. Yes, you are right. So Massey delta T of water is equal to Massey delta T of copper. Mass of water 45. Specific heat capacity 4.2, 42 upon 10 into delta T. Now see, initial temperature is 50 and final temperature is TF. Of course, now water loses the heat energy. So final temperature of water will be less than the initial temperature. But as I mentioned in the earlier numericals, that delta T must be always positive. So by that notion here we must write 50 minus TF. Okay, mass of copper 50 into specific heat capacity is 0.39, so 39 upon 100 into TF minus 18, because the temperature of copper increases. So final temperature is greater than initial temperature. 10 cancels here. Okay, 10 and 10 gets cancelled. 14 threes are 12, 14 threes are 42, and 13 threes are 39, 9 fives are 45. So now 14 into 9 into 50 minus TF is equal to 13 into TF minus 18. Okay. So this is how we can, see, if you see in this particular step, this is very crucial step. If you can do the maximum cancellation in that step, then the calorimetry numericals are very easy. Okay, so 114 into 9, that is 126 into 50 minus TF is equal to, let us open the bracket this side, So that gives us 13 TF minus 13 into 18 is 234. Let us open the bracket on the left side now. That is 126 into 50. That is 6300 minus 126 TF is equal to 13 TF minus 234. So that will be 6300 plus 234 is equal to 126 TF plus 13 TF. So 6300 plus 234, that is 6534 divided by, on the right hand side we have 126 TF plus 13 TF. 126 plus 13 is 139. 139 is equal to TF. So here our final answer is now 6534 divided by 139, and that is coming out 47.007. So we can say 47 degree Celsius is the final answer. 47 degree Celsius is final answer. So see, the final temperature is more than 18 but less than 50 degree Celsius. 11th, 200 gram of hot water at 80 degrees Celsius is added to 300 gram of cold water at 10 degrees Celsius. Neglecting the heat taken by the container, calculate the final temperature of the mixture. So let me start numerical directly by this statement. According to the principle of calorimetry, heat lost is equal to heat gain. Now we may ask this question, is it mandatory to write this every time? Answer is yes, it is mandatory to mention this opening statement always for calorimetry numericals. Heat lost, mass delta T, heat is lost by hot water is equal to mass delta T, heat is gained by cold water. Mass of hot water 200 gram, specific heat capacity is 4.2, delta T, delta T. So delta T is 80 minus TF is equal to mass of cold water 300 into specific heat capacity 4.2 into delta T is final temperature minus 10. Alright, 4.2 gets cancelled. Two zeros from left and right sides gets cancelled. So 2 into 80, 160. 160 minus 2 TF is equal to 3 TF minus 30. 160 plus 30, 190 is equal to 2 plus 3, 5 TF. So TF is equal to 190 divided by 5, which is 38 degree Celsius. 190 upon 5, 38 degree Celsius. 12th, the temperature of 600 gram of cold water rises by 15 degrees Celsius. So delta T is given 15 degrees Celsius for cold water. Remember, 15 degrees Celsius is neither initial nor final. It is change in the temperature for cold water. And this happens when 300 gram of hot water at 50 degrees Celsius is added to it. What was the initial temperature of cold water? So according to principle of calorimetry, or according to principle of mixture, heat lost is equal to heat gain. Heat lost by hot water, mass delta T of hot water is equal to mass delta T of cold water. Let me cancel C first. Now mass of hot water is 300 gram. Delta T of hot water initial temperature is known but final temperature is unknown. Final temperature of the mixture is not given in the question, right? Is equal to mass of cold water 600 into delta T is given here directly 15 degrees Celsius. So 300 times 2 600. 50 minus TF is equal to 30, and hence TF is equal to 50 minus 30 is equal to 20 degrees Celsius. So the final temperature of the mixture is 20 degrees Celsius. So this final temperature is applicable to cold water as well. Now for cold water, we know that initial temperature is less than the final temperature, right? Or final temperature is more than initial temperature. So for cold water, when we say delta T is equal to 15 degrees Celsius, this is final temperature minus initial temperature is equal to 15. Final temperature of the mixture is 20. So final temperature of cold water is also 20 minus Ti is equal to 15, and hence Ti is equal to 20 minus 15 is equal to 5 degree Celsius. So in this particular numerical, to find the initial temperature of cold water, we have to use this fact that delta T is final minus initial is equal to 15. So initial temperature of cold water is 5 degree Celsius. And we are on the last numerical of this exercise. 1 kg of water is contained in 1.25 kilowatt kettle. Calculate the time taken for the temperature of water to rise from 25 to its boiling point, 100 degrees Celsius. Now, this information may not be given in the exam. Okay, it may just mention that 25 degrees Celsius to the boiling point. So we should know what is the boiling point of water, 100 degrees Celsius. Specific heat capacity of water is given. So here we will not use the principle of calorimetry because it is not a method of mixture. It is electrical method, right? We are using electric energy to convert it into heat energy. So PT is equal to mass E delta T. Power 1.25 kilo, that is 1.25 into 1000, into time, that is what we want to find out. Mass of water 1 kilogram. Now specific heat capacity is given in joule per gram, but mass is given in kilogram. So we must take the value of specific heat capacity in joule per kilogram, which is 4200 joule per kg Kelvin. And what is delta T? 25 to 100. So delta T is 75. So the left side is 1250, right? 1.25 into 1000 will give us 1250 into T is equal to 4200 into 75. So T is equal to 4200 into 75 upon 1250. 25 5s are 125, 25 3s are 75. So this is 420 into 3 divided by 5. That is, we can say 420 into 6 divided by 10. 252 seconds. 252 seconds. That is, we can say 240 seconds plus 12 seconds. And 240 seconds is how many minutes? 4 minutes. 4 minutes and 12 seconds. But as I mentioned earlier as well, that you can keep the final answer in seconds, 252 seconds.
Thank you for watching. Please check the link in the description below for more numerical videos. Please like, share and subscribe to my channel.